Alright, this last video on this packet of notes here, 8 and 9, you can see how, since both the x's and the y's were squared, these are going to give us circles. Alright, that's the easiest part. We know how to graph circles. And then after we graph the circle, then we're going to do the main part where we're going to replace the x's and y's with r's and thetas. Alright, so number 8, if I graph this, it's really easy. I'd kind of put this over here. The center of the circle for number 8 is, what's it going to be, 0, 2. And then remember, it always equals r squared. So r squared is 4, which is going to give us 2 for the radius. All right, so really easy. I'm just going to graph this right away, and then we'll convert it to polar. So the center is at 0, 2, which is right here. All right. Then the radius is 2. Now this is real important to look at because we're going to see this is always going to happen for the examples that we do. Here's the center. The radius is 2. When I go down 2, I have that the origin is going to be a point on the circle. All right, and we've seen that for the other ones that we graphed before when it was in polar form. The origin was on the circle. And same thing's going to happen for the next one, number 9. So we're going to have a point there. We go up 2, we're going to have a point. We go to the right 2. Right here, we're going to have a point, and to the left 2. All right, so this should be real simple right here. So we go down 2. I can go to the left 2, up 2, and to the right 2. Connect the 4 points in red, and we have our circle. Right? Very simple. Okay, you can do that right away. All right, the main part. Let's get these x's and y's, and let's replace them. Now, remember when we did this before, and it was in polar form? When we completed the square, and for this one, the only one that's squared or has a shift is the y. This is where you're going to eventually have a sign in this. All right, so here's what we could do. I want to get x squared plus y squared because remember, x squared plus y squared equals the r squared. In order to get that, I'm going to FOIL this out. All right, so I'm just going to bring down the x squared. When I FOIL out the y minus 2 squared, we're going to get y squared minus 4y and then plus 4 equals 4. All right. And then one thing that we see right here also, see how these 4s, they're going to cancel out. All right, if you subtracted 4 from both sides, these just go away. So then, let's rewrite it. We just have 3 terms on this left side. X squared plus y squared minus 4y equals 0. Okay, and then here we have it. The x squared plus y squared is r squared. And then y, we're going to replace that with r times the sine of theta. So it's minus 4 times r sine of theta. All right. Now, just like the other ones, for 5, 6, and 7, the hint was solve for r. We're going to do the same thing. So to solve for r, I have 2 terms here, and the common factor, or GCF, would be r. So we're going to factor out an r. So we're going to have, when we factor that out, then this first term is going to be r. And in the second term, we take away this r, so it's just 4 times sine of theta equals 0. Then the 2 factors, you're just going to set each of these equal to 0. You're going to have r equals 0. That's kind of weird, but we're going to explain the significance of that. And then this, when you set this equal to 0, if you take r minus 4 sine of theta and set it equal to 0, and if you solve for r, you just add 4 sine of theta on both sides. So r is going to equal 4 sine of theta. All right. Now look at these two. This is what they mean. The main thing really is the 4 sine of theta. That's really the equation. So the 4 sine of theta gives us that graph. But the other thing here is you might think it's kind of random. Like, what does this r equals 0 mean? Well, think of it. If you graphed, well, where is the radius 0? Well, if the radius is 0, you're on the origin. See how it's that point right there? So you're going to see when you get r to equal 0, that's telling you that that graph better go through the origin, and it does in this case. All right, let's do the last one. Slide over and do 9. Okay, now 9, you can see you have both shifts for x and y. So we convert, we're going to have both sine and cosine in it. All right, but let's do the easy part. Let's graph this. So when we look at this, the center is going to be at -2, 3. Right? We always take the opposite signs in the parentheses. And then the 13 equals r squared. So r is going to equal the square root of 13, which is going to be around 3.6. All right, so it just gets a little bit ugly with the decimal. All right, so let's use that to graph. So let's go to -2, 3. Let's make this a little bit bigger. All right, so -2, 3. We go from the origin, we go to the left 2, up 3. 1, 2, 3, so it's right here. Now it was, what was it? R equals 3.6. I'm just writing it here to remind myself. So from there, I'm just going to go, let's see here, up 1, 2, 3.6. We get a point right there. 1, 2, 3.6. I want to go to the right. 1, 2, 3. 3.6 is right about here. I go down. 1, 2, 3.6 is right about here. To the left, 1, 2, 3.6 is right about there. All right, connect it. And that's about as good as I can do. All right, that's the easy part. That's the graph. Let's get to the harder part. I want to take this and I want to convert all these x's and y's to sines and cosines and to r's as well. And then solve for r. So just like number 8, we're going to FOIL both of these out. So I can get x squared plus y squared. So if I FOIL out the x plus 2 squared, we're going to get x squared plus 4x plus 4. If I FOIL out the y minus 3 squared, that's going to give us y squared minus 6y plus 9 equals 13. All right. Now another thing you're going to see that happened for number 8. Look at the constants 4 and 9. When I add 4 and the 9, see how I get this? So all those constants are going to wind up canceling out. You're going to see that's going to happen for all of these. All right. If it doesn't, then nothing's going to work out. So these cancel each other out. So then this is what we have. X squared plus 4x plus y squared minus 6y equals 0. Now, usually we group the x's together and the y's together, but really what I want to do is I want to group this together because that's going to give me r squared. So I'm just going to put r squared plus this 4x. I'm just going to replace that with 4 times r cosine of theta. This minus 6y, I'm going to replace that with minus 6 times the sine of theta. Or minus 6 times, whoops, forgot the r, times r times the sine of theta equals 0. All right, now that looks a little bit ugly, but just like the last one, what's common is I have at least an r or one r in all 3 of these terms. So in order to solve for r, we're going to factor out an r. And on the inside, we're going to get r plus, well, this r is going to go away, so it's going to be 4 cosine of theta minus, this r is going to go away, so it's just going to be 6 times the sine of theta equals 0. Okay, and then when we solve for it, see how we have this r equals 0? All right, that's going to correspond to a point on the circle that's going to go through the origin. Now, when you solve for r here, you wind up just taking the opposite of these. So it's going to wind up being -4 cosine of theta plus 6 sine of theta. That's really going to be our polar equation, which is going to give us this circle. All right, so this is really kind of the main thing. What this is telling us is, let's see if I kind of drew it to scale. Probably not, but we'll see. R equals 0. Oh, look at that. I actually did it right. See how I have this circle going through the origin? That's because I got that r to equal 0. All right, so you'll see all these circles, no matter of the numbers, these circles are always going to go through the origin. All right, so for these ones, graph the circle first, and then you always want to FOIL everything out and then get x squared plus y squared by itself and change it to r squared.